So this is a problem that I refer to as like a derivative concept question. It has the essentials of the necessity to take a derivative and understand what it means, but it's applied in a way that kind of have to know what's going on, what a derivative is finding for you, and some basic algebra kind of stuff before you can solve the problem. So the question asks us to determine the equation of a tangent line that would be tangent to the curve f of x equals 2 times the square root of x plus 1 if the tangent line happens to pass through the point negative 4, 0. So I gave a little graph here of the graph of 2 root of x plus 1, what that would look like. Of course, at x equals negative 1, the y value is going to be 0, and it's going to move up and out like a regular old square root function does. However, the point negative 4, 0 is over here. So if you could imagine a tangent line to this curve that would have to go through this point, it would probably have to, well, not probably, has to kind of look something like this maybe. It's going to shoot out that way. So the question is, what's the equation of this line? And that's, a little bit of a daunting question, but we know a few things. We know that the green line and the red curve are concurrent, or in other words, they crash into each other at some point right there. It'd be really nice to know what that point is. And so that's sort of going to be the key to this problem. We're going to recognize that that point has some x value, so we'll call it x, and its y value would simply be whatever the y value of that function is, which in this case is 2 times the root of x plus 1. And with that in mind, we can now set up kind of a little equation that's got to be true. First of all, we know in discovering the slope of that line that we could consider it from like what I refer to as like that 7th grade perspective of y2 minus y1 over x2 minus x1. That would result in this y value, which is 2 root of x plus 1, minus the y value down here, which is just simply 0, over x2, which is x, this guy, minus this guy, which would be minus negative 4. And that's all well and good. It's certainly a true representation of the slope of that line, just using, y2 minus y1 over x2 minus x1. But the thing that we benefit from in a calculus study is that we know that the slope from calculus is found using a derivative. So the calculus, which is going to be like f prime. So those two things have to agree with each other. It's not like when we get to calculus that suddenly algebra doesn't apply anymore. So what I need is a formula for the derivative of f of x, which is 2 times the quantity x plus 1 raised to the 1/2, which of course is just 2 root of x plus 1. So let's see what f prime would look like. Bring the 1/2 down in front, multiply it by that 2, and drop the power by 1, and then take the derivative of what's inside using a chain rule. And of course the derivative of x plus 1 is just simply 1, so that's kind of simple. This has been rigged pretty nicely. Those 2's cancel each other out, and we're left with 1 over x plus 1 to the 1/2, or if we want to choose to look at it as 1 over the root of x plus 1. So there's a formula for the slope of this red function at any x value. If you went out to an x value of, say, 8, plug an 8 in there, you'd get 8 plus 1 is 9, the square root of 9 is 3, so the slope would be 1/3. So way out here at x equals 8, the slope of this red curve would be 1/3. But at this x value, the slope is just 1 over root of x plus 1. So we can go back to our equation here and say our calculus slope is 1 over root of x plus 1. So this is now an equation that we can solve. The 7th grade slope has to be equal to the calculus slope. So if we can do a little algebra here, I'm suggesting maybe cross multiplying, we can determine what x value this is actually going to happen. So if we do cross multiply, we'll bring this up here, root of x plus 1 is getting multiplied by the 2 root of x plus 1 that's already there. It's really convenient. And then we multiply across this way, and x minus negative 4, which is x plus 4, is just getting multiplied by 1, so it's just x plus 4. The square root of x plus 1 squared is just going to be x plus 1. And so we have a really simple algebra problem here. 2x plus 2 is equal to x plus 4. Subtract 2 from both sides and subtract x from both sides, and we get x is equal to 2. And what that tells us is this point where the line is tangent to the curve is going to occur at x equals 2. The y value would just be what we get when we plug this in, which would be, that would be 3 in there, so we get 2 root 3. Not terribly important that we have that y value because we don't really need it. We do have to remember, though, that the problem did ask us to determine the equation of the tangent line. So we have this tangent line. And in order to do so, we just need a point and a slope. And yeah, we have that point, but we also have this point down here. He's just as much on the green line as that one is, and he's got nicer values. So why don't we use him? And we use our slope. Well, we have a formula for the slope, both here and here, but I think this one might be a little easier to plug into. So the slope of that line at x equals 2 would be f prime of 2, which is simply 1 over the root of 2 plus 1, which is 1 over root of 3. And I don't care if we leave it that way. Maybe we could write that as root 3 over 3 to clean it up, rationalize the denominator. So that is our slope, our m, if you will. And we have a point at negative 4 comma 0, so we can use point slope form. Y minus the y value equals m, which is the slope, root 3 over 3, x minus the x value, and maybe just clean that up to be y equals root 3 over 3 times the quantity x plus 4. And there's the equation of that tangent line. All right, there you go. Great example of calculus helping us out to determine something that seems really daunting at the outset.